Hello, my name is Oliver Mace, and I head the Research and Development Department here at ECOROLL AG. Today, I'd like to show you how you can find the right burnishing tool for your application in 3 simple steps. Roller burnishing is about smoothing or strengthening the surface through a mechanical post-treatment process. In this process, a rolling element, which can have various shapes, is pressed onto the surface with a defined force and rolls over it. Through this rolling motion, we achieve a continuous plastic deformation of the surface. The contact pressure is so high that we locally deform the roughness peaks, thereby smoothing the surface and creating a hardening of the subsurface zone. Now, this process is not very well known. This naturally makes it very difficult for you as a production manager, work planner, or machine operator to find the right tool. You have experience with cutting tools. You know which lathe tool or milling cutter to use for which machining geometry, which task you can handle with which cutting material, and you can request and order the right tool from your supplier. With burnishing tools, this experience is often lacking. Burnishing tools are not as well known. Therefore, we want to provide you with a tool in 3 simple steps to help you find the right tool for your needs. Basically, we distinguish between single roller mechanical, multi-roller mechanical tools, which are grouped as mechanical tools, and hydrostatic tools with and without a following system. Each tool has its own advantages and disadvantages. Their properties are somewhat different. I don't want to go into detail about that, but it's important that these different types of tools exist. With mechanical tools, a rolling roller is pressed into the surface via a mechanical force. This force can be generated in many different ways. It can be directly via the machine, via spring elements, or via servo motors. It doesn't matter at all. A mechanical force is applied. With hydrostatic tools, a rolling ball is pressed into the surface with a defined pressure. The ball is completely surrounded by a medium on half its surface and is, so to speak, hydrostatically supported in this medium. That's why they're called hydrostatic tools. The rolling pressure here is up to 400, sometimes even 600 bar, with which the ball is then pressed into the surface. If you, as a user, want to find the right tool now, you have a variety of options. Here is simply a representation of a few tools that we have in our portfolio. You see standard tools here, but you also see special tools that we have co-developed and adapted for customers. How are you supposed to find the right tool here without any potential experience in deep rolling or smooth burnishing? It's not that simple. Therefore, as I said, we have a 3-step framework that guides you step by step, allowing you to define the right tool for your needs at the end. To start with, of course, we first have to define the boundary conditions. So how and where do you want to use the tool? You need to know which machine are you using. How is the tool clamped into the machine? How does the tool need to be aligned? How heavy can the tool be? How large can the tool be? All of these are questions that are defined by the machine. The workpiece itself defines, of course, the basic geometry of the roller, the rolling element. Are there any interfering geometries that we need to consider? How is the workpiece clamped? All of these are questions that you have to answer here. And thirdly, we have the process, of course. So which material do we want to machine? How fast does the process need to be? How strong does the rolling force need to be that is applied? All of these are questions we need to look at when considering the process. When you start selecting the right tool, the very first question you should ask yourself is what you want to do. So what is the goal of the machining process? Why do you want to use this method? Do you want to smooth a surface? Do you want to deep roll a surface? Or do you want to perform a special case? Do you want to create a precision bore? We differentiate so significantly between these two, especially between these two processes, roller burnishing and deep rolling, because the processes place different requirements on the tools. Roller burnishing is only about smoothing a surface. This is very easily done and can also be checked afterwards. No special, process control is necessary here, no documentation, no additional measurement technology. With deep rolling, it's a bit different. In deep rolling, the rolling force is a very central process variable that determines the amount of hardening in the surface layer. The problem is you can't measure that non-destructively afterwards. Therefore, we have to place higher requirements on the documentation and the adjustability of the rolling force. And therefore, the tools for roller burnishing and deep rolling are slightly different in their requirements. That's why we have to clearly distinguish here whether we want to burnish a surface or even deep roll it. The second question is relatively easy to answer. What is the hardness of your material? Are we talking about soft machining? So do we have less than 45 HRC? Or are we talking about hard machining and we have more than 45 HRC? Of course, there is a higher load on the tools during hard machining, which is why we also have to place higher demands on the tools here. And thirdly, the crucial question, Which geometry do you want to machine? What is the basic geometry of the component you want to machine? So do you want to burnish a cylindrical surface? Do you want to deep roll a radius? All of these are questions or geometric shapes that you have to define. It's not about what the overall component looks like. So, of course, behind your cylindrical surface that you want to machine, you probably have a shoulder with a radius. But if that's not relevant, then you don't need to consider it, unless we have some interfering geometries or something like that. But those are detailed questions. To select the right tool first, it's crucial to know what basic geometry you have. We have a list here of various icons, and these icons describe different geometric shapes. So we have cylindrical surfaces, we have cylindrical bores, we have a cone, we have a taper. So we have various basic geometric shapes here, and these icons can be found in all our brochures on our website, in the tool descriptions. So basically, you'll find these icon shapes everywhere and can clearly say, we want this tool is suitable for this machining process, or it isn't. And to make this whole thing even easier for you, we recently launched the tool finder on our website. The tool finder is basically what I've briefly summarized for you in these 3 steps as software on the website. You can find your correct tools directly here by answering these 3 questions. If you do this, as we're about to do, you'll get a list of tools at the end that are relevant to your application. And so you can see how it works. I'd like to demonstrate it to you live.
Yes, this is our tool finder. The 3 steps are mapped out here accordingly. In the first step, you're asked what the goal of your machining is. Here you can choose between smoothing a surface, producing a precision bore, or hardening a surface. For the example, let's assume that we want to smooth a surface. Then the next question is the component hardness, the material hardness, either less than or greater than 45 HRC. Let's assume soft machining for the rest of the example. And then in the third step comes the selection of the various component geometries. Here you can see in color what kind of basic component geometry your part currently has. Select that and then proceed to the tool selection. For the example itself, let's assume a cylindrical outer contour. And then the corresponding tools are displayed below that with a corresponding list. All tools that basically meet these requirements are listed here. If we take a look at this, perhaps using the example of the EG5 tool, then in the overview, we have the choice at the top again, whether it's a single roller, multi-roller, or hydrostatic tool. We have the tool designation, we have the classification again, whether it's roller burnishing, deep rolling, or Skive-Burnishing. Then we have a short description of the tool, a visual representation of the tool, and below the visual representation, once again, geometry data. For example, this tool can be used for diameters from 10 to 70 millimeters. And below that is also a very nice overview. You can find, so to speak, the flexibility of the tool. So for which geometric shapes this tool is also suitable, you can then see right here below. And when you are satisfied with the selection, then you can go via the link to the product page, to the actual product page, and then get detailed information about the tool.